All right, welcome to lesson 5.1. In this lesson, we're going to be looking at the derivative of y equals e to the x. So the first thing that we need to talk about is the number e. So the number e is a special mathematical constant, kind of like the number pi. So it looks like we're using a variable, but really e represents one specific number. It's called Euler's number, or the natural number. So we're going to go through an investigation, a two-step investigation. I'd like you to pause the video, go over to Desmos, and follow through these instructions and see if you can figure out what you notice there. All right, so hopefully you've gone through the investigation. I'm going to go over to Desmos just in case you didn't. And when I type in the letter E, the number or the numeric equivalent pops up here. So normally when we talk about the number E, we would just use 2.718 or 2.72 if you wanted to round even further. So heading back here, hopefully we've got that number filled in. E is about equal to 2.718. So I'm kind of remembering that I'm always going to write down the letter E to represent this special number. But I'm kind of, sometimes it's nice, kind of like with pi, to know what it's about equal to. All right, so next we're heading over and we're typing in f at x equals e to the x. And then we wanted to add a table to this. So we can see the graph here. It's an exponential graph. It looks kind of familiar, right? We're going to add a table. So we click on this gear wheel up here, and then we click on the table icon. And in the table, I'm going to add a new column. So I already have a column for x, a column for the function. And if I click off to the side, hopefully you know this, you can click in here and you could add more numbers if you wanted. And when you add them, they show up on the graph as points. I can't type into the y column or the f at x column, but I can type into the x. And then heading over, I can actually type a second equation in here, and I'm going to type in the equation for the derivative. And what happened here is they added the points for the derivative in black on top of my green graph here. And so hopefully what you notice is these are the same points as the green graph. And you can actually just graph the entire thing for the derivative of f. So here in green I had the original function, and notice that there it shows up in green, and then when I click here the derivative will show up in blue and it's right on top. So this is one of the reasons why this is such a special number. What I notice is it's the same graph. And what this means then, our conclusion, is that if our function given is e to the power of x, then the derivative is also e to the power of x. This is a nice easy one to take the derivative of. I don't change anything. So let's do a chain rule on this. What if I have e to the power of some equation? So maybe I've got like e to the power of 2x plus 1 or something like that, right? There's some other g at x equation in the exponent. And then to take the derivative, I take the derivative of the outer function. The outer function is e to the power of x, so nothing changes. I just copy it down exactly as it was, e to the power of g of x. And then I multiply by the derivative of the inner function. Now the inner function is the exponent, so just taking the derivative of that exponent. All right, so we're going to do a couple examples to practice here. Finding the derivative of this function here, I have a product rule, which I can't simplify. Remember that the -5 out front, this is just a multiplier. It's not part of my quotient, or my product rule. I can include it in my product rule if I want, or I can leave it factored out while I take the derivative, and that's what I'm going to do. But you'll get the same answer if you maybe you view it as part of the x to the power of 3 function. That's fine. So I've got two pieces to my function. I'm going to call them u, this is the x cubed bit, and v, that's the e to the 3x. And I'm going to go through the product rule. And so taking the derivative of the first function, x cubed, that's 3x squared. And then I move on to just copying down the v function, so e to the power of 3x. And now I'm going to add. This time I leave u alone, that's the x cubed. And then I'm going to take the derivative of v. So this is the new bit. I've got e to the power of something. So whenever I've got that base e, I'm just going to copy it down exactly as it was. And then I'll take the derivative of the exponent afterwards. So my exponent is 3x. The derivative of that is just 3. And now we'll clean this up to simplify. I've already got the -5 factored out, which is kind of nice. If you did include it as part of your u function, then you'll have to common factor it out now. I'm looking for things that are in common in these two terms, and I notice that they both have a multiplier of 3. They both have an x. This one's got 2 x's, this one's got 3, so I'll take out 2 of them. And then they both have an e to the 3x. So lots of stuff for me to pull out as a common factor. So I'm going to pull out the 3. I'm going to pull out an x squared, and you don't need the dots. Here, you could have used brackets around your 3 as well. And then I'm going to pull out an e to the 3x. And so what's left over? In the first term, I've actually divided out exactly the first term. So I'm left with a 1. It is not 0 when you divide something by itself. It is 1. And then adding here, I've divided everything except one of the x's is still there. And then normally we would just switch the order of this bracket in simplest form, and we'll multiply these two coefficients. All right, moving on to the next example here. I'm going to take the derivative, and I have something with x's divided by something with x's. So I do have a quotient rule. I'm thinking of the numerator as u and the denominator is v, and I'm remembering my quotient rule. And I'm going to go through these pieces. So taking the derivative of the numerator is 2 is the common multiplier, and then the derivative of e to the x, remember, is just e to the x. So there, I've actually taken the derivative even though it looks like the original thing. And now I'll multiply by the denominator and then subtract. This time I'm going to leave the numerator alone, which was the same as taking the derivative of it. And then I'm going to take the derivative of the denominator. And then we'll put that all over the old denominator squared. Again, trying to clean this up. I'm looking for common multiples or common factors in the two terms in the numerator. I see that there's a common factor of 2 and a common factor of e to the x. So I'm going to bring those out. Oops. And in the first term, I'm left with x minus 3, and in the second term, I'm left with -1. And there we are in simplest form. All right, for example 2, we're asked to find the equation of the tangent to h at x at a given x value of 1. So to find the equation of the tangent, we know that we need to find the point and the slope. So I'm going to start by finding the point. Doesn't matter. And so I'm going to plug the given x value into the original function. And so there I get my y value, and I have a point at 1 comma -2 over e squared. So now I'm going to go and find the slope. And so to find the slope, I need to find the first derivative of our function. Now I've got a quotient rule here, so I'm going to take the derivative of the numerator. I'm thinking about my quotient rule is if I have f over g, then I do f prime g minus fg prime all over g squared. So I'm going to work my way through this. The derivative of the top is -8x cubed times the denominator. And then we'll subtract. So we've done the first two pieces. Now we're going to subtract. This time we leave the numerator alone and multiply by the derivative of the denominator. So I leave the e to the 2x as it is, and then I take the derivative of the exponent. And I put that all over the old denominator squared. All right, so we're going to clean this up a little bit, and then we're going to try, and remember at any point now I can sub in the value of x equals 1, because that's all I care about. So you can factor this, or you can just substitute in. So I'm going to just simplify it a little bit. And so for my new exponent here, I'm going to have 2x times 2, so that's 4x. And I can continue to simplify this. I'm going to do it just as an exercise, but really at this point, if you want to sub in the x value of 1, then you can. So here I see that there's a common factor of 4. I am just going to take out 1, 4, because I actually see that there's a higher exponent on x over here than here. So I want this one to stay positive, but you could take out a -4 and then you'll just realize the error later. So I'm pulling out all of my common factors. So I looked first at my coefficients, I pulled out a 4, then looking at the x's, I saw that there was an x to the 3, and then I saw the e to the 2x. So if the highlighting helps, I looked at these guys, then at these ones, and then these ones. And so now that I've got my common factor figured out, I'm going to open up my set of brackets and divide my first term by this common factor. And all that's left is -2 from the coefficients. Everything else divided away to equal 1. And then moving on to the second term, when I divide these ones out, I get x, and everything else divided away to equal 1. So I just get x minus 2 here in this bracket. You can reorganize that bracket. If I was asking for it in simplified form, you should, but we just want the slope at x equals 1, so I'm going to plug in 1. And so in the bracket, I'm going to get -2 plus 1. And then when we simplify this all down here, I've got a -4 e squared all over e to the power of 4. And I can use my exponent laws. My exponent laws say that if I have the same base, I can subtract the exponents when they're being divided. So when I subtract the exponents, I get e to the -2. 2 minus 4 is -2, but that's just the same as -4 over e squared. So you could have also thought about canceling here, and you would have gotten to the same answer. All right, so we've got our slope, we've got our point, we're going to come up with our equation. We know that the equation is y equals mx plus b, and this is our slope of our tangent at x equals 1. And so to figure out the b value of this equation, we'll sub in the point at x equals 1. That was -2 over e squared was our y value that we found. And then I'll rearrange to solve for b. And this one's nice, it's already got a common denominator for us, so I just need to add those exponents, or sorry, those numerators. I've got my b value. So there's my answer in y equals mx plus b form. If the question specified that I need standard form, I would multiply through by e squared. And then rearrange so that the coefficient on the x term is positive. All right, have fun with your homework.